Okay, hello everyone. Welcome to today's Cutter webinar, Big Data Strategies for Agile Business. My name is Rich Whalen. I'm the host of this session. And before I turn it over to Dr. Bhuvan Unhelkar, I will have just some housekeeping things to take care of and a little bit to tell you about before we start. As you can see, this slide tells you a little bit about Cutter Consortium. One of the most important things we want to focus on is our access to the experts approach. We have absolutely no ties to vendors whatsoever, so everything you're hearing is based on experience and not under the influence of any vendor in any field at all. And before we hand things over to Bhuvan, I want to just go over a little housekeeping about your audio settings. On the right-hand side of your screen, you'll see a toolbar there that how you can change your audio settings. Most of you have probably are listening through your computer, but if you wanted to, you could dial in to the session, and there are options there how you can get that phone number to dial in. When you do dial in, you will be muted and you wouldn't be able to speak in the webinar. We'll do a questions at the end, and that's where you have the questions box in there that you can type in your questions. You can type in a question or comment at any time during the session. I will be monitoring those, and if it pertains to the logistics of the session, or if you're having any issues hearing anything or so forth, I would respond to you privately via chat. And now a little bit about Bhuvan Unhelkar. He's a Cutter Senior Consultant, Associate Professor, and Head of IT USF Sarasota Manatee. He's also founder of MethodScience.com. He's visiting faculty at the University of Technology, Sydney as well. He is supervisor with 7 PhD completions, fellow of the Australian Computer Society, life member, Computer Society of India, and Baroda Management Association. A lot of information on Bhuvan there, and right now I will turn it over to him. Welcome, Bhuvan.
Thank you, Rich, and welcome to everyone. My name is Bhuvan Unhelkar, and I'm sitting here in my office of University of South Florida, Sarasota Manatee campus. So, hello from sunny Sarasota. But as you would guess, I have an Indian background, but that's not where it ends. I am an Australian, and for last 29 years, before I moved to University of South Florida, I have been in Sydney, Australia. And that's where I did my research and also operated Method Science as my consulting company. Now, when I was invited by Cutter, and some of you may have seen my reports and updates, which I thoroughly enjoy contributing to Cutter. One of the things that was mentioned to me was to see if I could present big data at a management or decision-making level. And I thought perhaps the best way to do that would be to see what exactly is business looking for, whether it is big data or small data or any kind of data, information, knowledge. So I would like to pitch my value generation from big data at this particular slide, this particular 2 words: Agile business. Now, Agile itself has been a very popular term, but what I mean by Agile business is what I would like to share with you, if I can. Let me see. Okay, that is, that's a bit of writing that I have been doing for Cutter in the space of agility. And if you have access to these reports and updates, you will find my view of what is Agile. But if you And I might as well add that I wrote this book a couple of years back, primarily focused on the value that Agile can deliver at an organizational level. But this is my view of Agile at organizational level. And if I have to focus the work I do in big data, the work we all do in big data, then it will be to add more to the agility at organizational level. Most of us are comfortable now with agile methods. Scrum and extreme programming are well known. But these methods have focused on providing solutions, primarily in IT projects, software projects. What I have argued for is the importance and the value of Agile across the entire organization. And that means having an Agile culture. That means having a decentralized or collaborative means of making decisions, and those decisions are also highly personalized and customized to what the user wants. They are very, very fine, granular decisions. Now, if this is what I want out of Agile at an organizational level, I want technology to support that. And that's where I'm pitching big data. There is a philosophical difference and a conceptual similarity between big data and data. First and foremost, it's data. It contains bits and bytes. It can grow in size. It can change. It can have quality issues. And it has got hidden patterns in it. So that's true of data and big data. What is different is the level to which we can analyze the data that is in thousands of times, thousands of multiples more than what we are used to, and the granularity to which we can take the analytics, to an individual customer on a particular day, walking through a particular aisle of a supermarket, and we are able to send a coupon to that customer at that time, is made possible because of data, that is big data, and big analytics that go with the data. So my pitch is agile organization and big data, both technologies and analytics, as its enablers. So let's have a look at the classic definition of what is big data, and then how it can be used for agility in organizations. Now, this is not a new slide, new material in terms of what defines big data. It has high volume. It has high velocity. The speed with which data is coming in is very high. And it is not just text. It is audio data. In fact, a seminar like this, a webinar like this getting recorded is creating audio data, which is not analyzable the way we would analyze a text data. And then there is video data, and then there are machine sensors, and we all are carrying our Fitbit and our cell phones, which are recording how many steps we took, and our GPS navigation instruments. all of them are generating data without us interfering or suggesting. So we have got variety of data. Then of course we have got veracity, or in simple terms, quality of that data, which is also changing. Now, if we look at these 4 V's, 3 plus 1, we find that these are all fuzzy, approximate definitions of what is big data, because I don't think there is a cutoff or a precise point beyond which I can say it is big data. Okay, common sense knowledge, I am looking at a petabyte of data, that must be big. That's volume. I am looking at data coming in at a very high speed, 100 megabytes per second. Maybe that's big data in terms of velocity. I have got variety. Yes, I agree, that's big data. And the source and quality. I find that the best way to understand what could be called big is our limitations in terms of analyzing it, in terms of making sense out of it. And the moment we hit that challenge, we try and say that is big. And to me, the technologies of Hadoop and MapReduce and associated big data technologies have made it possible for us to handle what was otherwise so big that we could not have made sense out of it. So then the question arises, why are we doing all this? Why should we handle large volume and velocity and variety? Because of one V that is right now not appearing in the big data literature, but it is something that I have inserted in my book with CRC Press, which is actually having the same title as that of this webinar, and that is V for value. Now, you have a right to ask, if volume, velocity, and variety cannot be defined, how can we define value? And again, I agree that there is no precise definition of value, except for the fact that if I can pinpoint to the finest granularity what my user, which includes my customer and which also includes my decision makers in my organizations, to a level where they are able to take decisions that provide satisfaction and growth for my business, I am providing value. That's one rough way of looking at value. And we are handling volume, velocity, variety, and the veracity of data in order to generate value for our business. So in terms of positioning big data as a strategy, this is my take, which I have explained just now. Whenever we punch in the terms big data strategies, I find one of these 2 things coming up in all my search engines. One, I get all technologies, a list of HDFS, Hadoop distributed systems, and MapReduce are the basic technologies on which everything else is built. And then of course I get all the packages. I get Cloudera, and I get whatever Amazon and Google is offering. And that to me is the entire suite of technologies that enable analytics to happen. If I look at the other side of big data, then it is heavily focused on statistical analytical techniques. And both of these are important. We have technologies that can help us handle the large amount of data and its volume, and we have algorithms and models that help us statistically analyze data. But is that a strategic use of big data? Is that what is going to help us achieve business agility, which is our value system? And I think we need, as a community, as a group, as a group of thinkers and practitioners who are interested in big data, to come up with a framework, a strategic approach that will help a organization, especially medium to large sized organization, start looking at business value from big data. And that's where my focus of big data is. Now, I mentioned technologies and analytics. A brief recap for you. If you haven't heard, and I'm sure most of you do know about this, that Doug Cutting's work on Hadoop has been the basic revolution in the big data space. And if I have to describe it in a layperson's language, then instead of using one single large computing power to analyze a large set of data, Hadoop is distributing that data over tens of thousands of small commodity computers or laptop sized computers, and that is providing the ability to do massive parallel processing and also redundancy, because the architecture of Hadoop ensures that a node breaking down is not a big deal as it would be if one single machine broke down. And this in turn spawned off a whole suite of technologies. And this is also for your information, slightly busy slide, but I have more details. If you want offline, feel free to contact. But we have got infrastructure technologies, which is really the keyword there is cloud. And then we have got storage and integration. So I have placed Hadoop and MapReduce over there, which can and in fact does work within the cloud, but you can have your own installation on your own laptop. We have got the whole suite of NoSQL databases. We have got starting with key value pairs, React, through to the highly popular MongoDB, short form for humongous database. It's document-centric database. Cloudera for handling billion rows and million columns, all emanating from Bigtable, the 2006 paper, Google's Bigtable. And then there is something like Neo4j, which is a graphic NoSQL database. So this is the suite of technologies. And when it comes to analytics, I just put a couple of slides there to remind us something like a net promoter score, extremely popular to figure out how my company, how my bank or my airline or my telecom company is perceived by the user community. And again, there is a fair bit of statistics underneath a net promoter score, but it has been one benchmark that you and I as a user come across quite often when we are asked to rate a particular service. And net promoter score is basically the percentage promoters, those who select 9 and 10, minus the percentage detractors who select between 0 and 6 as a rating for the quality and the satisfaction of a product or a service. So this leads to a series of or a variety of analytics, and the three that are most common or most popular are descriptive, predictive, and prescriptive. But I thought it may be worth expanding the categories of these analytics so that we have a better reason to focus if we are developing analytics on the purpose of a particular analytical solution. So I have gone into slightly more details of, some are informative, some are simply describing a situation without doing anything about it. Some analytics, especially used in manufacturing, aircraft maintenance, and so on, are diagnostics because they are particularly focused on identifying a problem which may be hidden. And then I have also added what I call exploratory, because I find that there are times when organizations simply like to explore what this data is providing without any particular goal. And so I just thought I'll add that here. On the right hand side, though, I am focusing on growth for a business, new products, new markets, optimization, that is improving on supply chain, inventory management, logistics that are used to provide the inventory or the goods. And then, of course, there is an angle to my view of big data, which is also sustainability in business and environment. And risk management and risk compliance, probably one of the biggest value that big data can provide, because of the way it can absorb the large data streams, not just in-house, but also coming from the government and other publicly available data streams. So that then takes us to these simple examples of what a technologist would ask in terms of big data, what a analyst, statistical person would ask about big data, and then what would be a more strategic question to ask of big data. So these are just examples, and of course we have got roles. We have got data scientist, data analyst, process modelers, and so on. And sometimes a data scientist could be asking all three questions because that is a role that I associate very, very closely with business while being aware of technology rather than the other way around. So here, customer service excellence, growth opportunities, process optimization, risk and compliance, and sustainability and environment are some of the strategic values that we can get out of big data. So then the first question that I asked us all is, if I have to achieve value, what's the path? What's the approach I should take? There are banks in Sydney, Australia that I was consulting to up until last year who are having a small cell that is simply creating Hadoop single node, multi-node installations and experimenting with it. And then there are people from the statistical and decision science stream who are trying to figure out what would be the best algorithms to make meaning out of data. I thought that there are so many factors that need to be brought together for big data success that for over the last 2.5 years, I have worked on putting them in one single framework. And I have called that Big Data Framework for Agile Business. And right now it's version 2.5. When it gets published, maybe I'll call it version 3.0. If you who are listening have some feedback and I incorporate that, I will increase the version number. But this is my view of the entire framework. And in fact, there is a Qatar article that I have published in a journal, in Qatar IT journal, on this framework. This is the smaller or the abstract version of the framework, the detailed one being far more detailed, is right now not publishable, if you like, in a journal. It needs a fairly large printout and perhaps needs to be converted into a tool. But it is something that I believe will provide value to business, because it will enable this transition from where the business is into what I have called agile business, making use of big data technologies and big data analytics. So to roughly define the framework for you, I'm starting with agile business values. And these values, as I mentioned to you earlier, are focused on providing better service, fine granular service to customers, having ability to change business processes dynamically, to have lean production processes or service processes, to have the ability to fail fast, which is a very valuable agile value. So those are my goals from a business viewpoint. And then I have defined 10 different roles, starting with the investor or the owner or the CEO of an organization, who actually starts with a SWOT analysis rather than a Hadoop installation. And then I've got these 5 building blocks: the business decision block, the data and technology block, the analytics and process modeling and process optimization block, enterprise architecture, semantic web, and the stack block, as I call it. And then finally, most importantly, the people and their skills block. And I have used the skills framework for information age, SIFIA, to map the skills and capabilities required from business strategy, technology, and analytics and quality viewpoint for big data adoption. I have some templates, inputs and outputs, some parameters that help me define a business. Obviously, big data for a small business. And here in Sarasota and Tampa Bay area, we have quite a few small businesses. Big data means slightly different thing to a small business than to a large bank or an airline. And understanding the status of that business, the current maturity of that business, is a very helpful input in this framework. I have also used composite agile rather than pure agile, as I call it, to list 13 key practices. Stories and stand-ups and showcases and retrospectives are all very helpful, not just in building a big data solution, but also deploying the processes out in the organization. So I'm looking at it more like a cultural, agile culture rather than agile method. I have then a reference layer, which I have called a compendium. It is made up of a adoption process, which can really translate into a project plan, but a iterative and incremental project plan with 12 lanes and 4 iterations, strategy cube, and then a big data manifesto made up of 5 statements, which is, as we speak, being circulated amongst those who are interested. And then I plan to publish that as a manifesto statement for big data. So this comprises the big data framework for agile business. And the way I would use the framework is to go into each of these building blocks in an iterative and incremental manner, to go through technologies, through analytics, through enterprise architecture, and not forgetting upskilling my staff, my people. So I don't have the time, of course, right now to take you through the entire framework. Do please read the Qatar article in the June issue of Qatar IT Journal, which outlines what I have explained in a little more detail. But then, as an example, let me show you a couple of things that I would be doing as I go deeper into this framework. For example, if I have to capture requirements for a business process, then I would be using what I call a use case. I apologize for the slightly busier slide over here, but let's say my business problem is whether I should increase the credit interest rate in my bank. Now that's a decision that is going to be made up of multiple factors, and the big data framework helps an organization pool these factors together. For example, what my competitors are doing, how my current user group, my customer group is performing, what is the cross section from where my banking customers who are looking for credit are coming. So you can see here I have provided use cases that are feeding into the main use case, and the way I am using the term use case is actually more closer to the original UML use case that Ivar Jakobsen had used. I'm not simply calling it a case study, which is what currently I find the big data literature contains. I'm using it as the way a actor or a user will use the solution, will use the business process to find value, to achieve his or her goals. So in here you find that there is one key decision which is made up of user profiles, borrowing cost, current balance trend, and so on. But then there are the ones in shade or yellow color use cases which are not directly discernible by doing normal analytics. And this is where the fine granularity of analytics comes in. There are customer sentiments, there are context engines to be referred to, community sentiments, and so on. So the way I'm seeing it, we can go up to 3 layers of use cases feeding into each other to arrive at a decision. So this is what big data framework for agile business is trying to achieve. I mentioned this article to you a few times. Do please have a look at it. Now, where can such a framework be applied? It has been applied in a small way right now, but in some larger projects, I have mapped the framework to some of the activities that have happened in big businesses. There are gaps, and those gaps can be fulfilled by applying the missing building blocks of BDFAB or Big Data Framework for Agile Business in some of the large big data adoptions. So here are some examples. For example, in agricultural domain, excuse me, I find that here they have started with machine sensors, which is a great way to start a project which is in agriculture or in mining. And both agriculture and mining are one of the top fuelers of economy, if you like, in Australia, because Australia is an agriculture and mining economy. So here I find that starting with the machine sensors through to logistics and supply chain, there has been a utilization of analytics. What I find even more interesting here is another keyword that I use with big data analytics. The first one being fine granularity is collaboration. If you were to ask me the differences between data and big data, collaboration is one word that comes to mind, because I am able to access, ingest, and analyze data that is far widespread. For example, weather data made available by the government in an open data public forum can be used by me to analyze whether I should be harvesting my wheat crop or sugarcane or barley today or tomorrow, or in 1 week's time or 2 weeks' time. So those are the kind of things that are possible through the analytics of big data at a business level, at a strategic level. Another field that is already benefiting, if not poised to benefit even more, is the health sector. And here I have, of course, taken these values coming from the reference that I have provided, but faster time to treatment, reduced readmissions, and right through to improved medication therapy management. Because through analytics and sensors in particular, I can use a watch or a button on my apparel to provide information to a patient in terms of his or her medications. So big data is poised to play a major role in the health sector as well. I'm not mentioning insurance right now because insurance is a beneficiary, but it is bringing in very interesting questions bordering on sociology and ethics and morality in terms of whether I should be insured or not based on my profile. Similarly, when we talk about fraud and crime, big data is a technology and analytics collaboration, if you like, that is going to provide immense value in identifying areas for crime, areas where financial crime in particular could be happening through those billion rows and million column data warehouses. I did find James Ricard's work quite fascinating, and I have yet to read his latest publication, but the one that I have gone through, The Death of Money, is 2014, and the new case for gold 2016, which I have not yet read. But in Death of Money, James Ricard has explained quite well the correlations that he arrived at between how a stock market was performing and the terrorist events that ensued 2 or 3 days after the performance of the stock market. So I think that the ability of big data to look at data stores that are far removed from the first line, the first level of use cases and decision making is one of the biggest value that big data is giving us and is likely to give us. And handling crime, being able to predict human generated disasters, and being able to trace financial transactions is something that the technologies are offering us. So I have covered thus far in my talk the description of what is considered big data, which is analytics and technologies. I explained Hadoop very briefly and NoSQL as technologies, and I highlighted Net Promoter Score as an example of analytics. I have then argued that both technologies and analytics are important, but they are themselves not strategies. So we need business strategies that will help us make use of what these technologies and analytics are offering. And those strategies are in 4 areas. That's my strategy cube. One is looking for major new growth in terms of products and services, in terms of the markets in which my company is pitching its products and services. In terms of optimization, inventory management, supply chain, and HR can be optimized much better with the help of big data. That's the strategic push. Risk and compliance, and GRC, governance, risk and control, is a very popular 3-letter acronym that demands more and more attention with all the rules and regulations surrounding large business in particular. And then the 4th is sustainability and the environment, how I can run my business in a sustainable manner. I have then said that we need a framework that will bring in all these factors together, help us view these factors that are impacting my move to a strategic agile business. I need to see them in one go, and that's what I have called big data framework for agile business. So in the BDFAB, I have created layers starting with the agile values, the roles, the building blocks, the artifacts or deliverable templates, the business parameters, the agile practices or composite agile practices as I call them, and then the 12 lanes for actual adoption and a big data manifesto. So this is what I have presented to you. I have taken about 45 minutes to do so, so we have between 10 to 15 minutes to answer any questions or have a bit of discussion or feedback from all of you. But I would definitely like to take the opportunity to thank you for listening to me.
Okay, great. Thank you, Bhuvan. Why don't you take a drink of water and a deep breath there before we get to the questions. And just a reminder, everyone, this is where you can ask questions. You can type them in the questions box on the right toolbar on the right-hand side, and we'll get to them as they come in. The first question, pretty straightforward, is what do you think the impact of big data will be 10 years from now?
Well, you can see in my conclusions and future directions, you and I are looking at a crystal ball. And I was just looking at one of those WhatsApp messages, friends forwarding, and there is a huge cabinet, the size of this cabinet behind me, and 4 burly men are pushing that cabinet, loading it on a truck. This is a photograph of 1957. This is a IBM cabinet containing a massive 5 megabyte of data. So in 1957, 5 megabyte was big data. And today, you and I are carrying 64 to 128 gigabytes in our back pocket with our phone. So what is the future of big data? Well, in 10 years from now, definitely what you and I call big data will not be big data. It will just be plain data. And there is no cutoff or benchmark for it, but the criteria that I will apply is my limitations to analyze the data that is coming in. There are other technologies that are going to feed into big data. For example, drones, which are right now still limited in use. 10 years from now, I see them becoming a common mechanism for observation and for transportation of small goods and so on. So they are going to feed into big data of 10 years from now. Most of the new cars that are coming in are equipped with eyesight technology. We had the self-driving car pioneer, I forget his name now, but he was visiting Australia just 3 months ago during our summer over here. And he's saying his children, his sons, will not need a driver's license to drive a car, because from 7 years, according to him, from now, when they become license ready, there will be self-driving cars on our roads. So the way we are seeing big data right now, it will not be big data. There will be a phenomenal amount of collaboration and integration between various data suites. There will be a lot of open access data. In fact, the Australian Computer Society has put a 12-point memo to the Australian government on the importance and value of open data platforms and how they enhance the economy. In fact, they are a means to fueling economy, and that I think will be even more integrated. Bioinformatics will come in. Most of us using iPhones and Android also are able to open up our phones without a password. So I can use my thumb impression, I can use my voice commands. So I see all of that feeding into what is called big data. And then I find the granularity of analytics becoming absolute, very fine if I have to predict 10 years from now, which means each and every day, each and every minute, my businesses are able to take decisions whether I need to increase the price or I need to provide more, I need to stock up more products in a particular warehouse, or I need to go to the hospital, for example. So I see all of that changing, and holographic images for visualization. I haven't touched the big topic of visualization, although it appears in BDFAB, but the way we are presenting information and the way we are interfacing, including this webinar, it's still two-dimensional. 10 years from now, I would assume that holographic images, three-dimensional presentations, and sensor mechanics will be sophisticated enough to take my big data analytics and present it in a completely unimaginable way right now. So that's my long and short of viewing big data 10 years from now.
Great. The next question. A marriage of big data with agility is an interesting concept. Could you share some large projects that have already implemented this novel approach?
I can share the starting points of these projects because the whole thing is new. Agility has been, not just Scrum, by the way, and extreme programming, but Agile in a macro sense has been popular with its own challenges. So when I started looking at technologies and analytics, I thought we the IT community is at a risk of doing the same potential mistakes that we do when a new technology comes, and that is we get heavily involved in the technology itself. Object-oriented technologies came, and then now NoSQL databases, fascinating technologies to play around with. The importance of these technologies and analytics needed to be translated. So there are 4 different organizations, 2 banks, one of which I can name, which is Rabobank, which is a Dutch bank with a large presence in Sydney, and being an agricultural bank, it is quite popular as Australia is an agricultural economy. And they have started with Agile at an organizational level, and they are trying to plug in or use big data at a very root or basic level. So by no means the project is complete. It is in experimentation stage, but that's one place where Agile and big data is coming together. Another is a company called Valued Communities, and again, it's a community-based forum, and it is trying to use Agile as its value system and big data as a enabler. But being a relatively small organization, it doesn't have the right now the necessary funds to go out. But the people who work there and I have been chatting about using low-level Hadoop installations to analyze the data that is coming in. They have the challenge of having to analyze both static and dynamic data. Again, the difference between data and big data is big data from a technology viewpoint came about through Hadoop. And Hadoop and MapReduce is a technology combo that is ideally suited to analyze massive amount of relatively static data. So I can go through last 100 years of weather patterns, temperatures, tsunamis, tornadoes, and I can do all that analysis. That data is not changing, that data is static. When I talk about business agility, we can't afford to analyze large static data only. We need to bring in dynamically changing data, which is changing today. And that is what we need what we needed when it came to modeling valued communities. So that's where we did the experiment. And then we have done a small travel business, but then small business is not equipped to install Hadoop or NoSQL. They are going to go more with something like Google Analytics and packages that are available. So to them, the value comes from showing how this data can be used in their business processes. So a lot of UML-based use case modeling, activity graphs, even BPM, business process modeling using BPMN, was used to model travel business processes. So that's where the marriage between Agile and big data is happening in the industry. I've got 2 PhDs starting or have started now in Australia, and I'm co-supervising because I'm physically located in Sarasota, and they are now experimenting with contextualizing context. Now, context is another big word that can take an hour, if not more, to explain. There is a context engine. There are 6 parameters that this hex elementization theory has created. And that is also an article by Girish Nair, who is my student, along with his supervisor, Professor Yi Chen Lan, in that same Qatar IT Journal June issue. And that particular PhD research is trying to figure out how a data point with 6 parameters can be matched with another data point with another 6 parameters, and which of those 6 parameters will come together. Now, why should we do this? For business agility, to be able to take fine granular insights into decision making. And so those are a couple of research projects that have started in terms of marrying Agile to big data.
Okay, great. We could just do a Q&A session on this topic. The questions keep rolling in. What should major criteria to select a partner to help with big data strategy and its implementation?
Okay. Now, there are a vast array of products, and each product. So, I don't want to name it because we in Qatar are product agnostic. But there are products, from a database side, there is MongoDB. From a package side, Cloudera. There are cloud solutions themselves. Each package or each product seems to offer everything. Storage of data, security and privacy, ability to ingest high velocity, undertaking analytics, doing various configuration for analytics, visualization or presentation in many different forms, helping out a community of users, or forming a community of users. These are some of the stock standard criteria that we would use to select not just a big data product, any product, but the nuances of big data start appearing. And as I mentioned to you, level of granularity in terms of analytics and collaboration. My understanding and my experience is that most large organizations, and I'm talking to a few, although I may not have actually worked with them right now here, they are saying, Bhuvan, great, big data, you have sold us the concept. We already have a large amount of structured data, because structure can be large, big, but it is structured, it is accessible through structured query language, it is sitting in rows and columns. This is the data sitting in most SAP or JD Edward or PeopleSoft or any ERP solution, any CRM solution, any supply chain solution. What to do with this data? So when you are looking for a big data solution, a product, my recommendation would be to go through the list that I just now read out in terms of privacy, security, storage, and so on. But check how easy it is or difficult for you to interface and integrate this new big data solution with your existing large amount of data. And that will be my key criteria for selecting a particular big data product.
Okay, great. Thank you, Bhuvan. The next question, what is the relation of big data with enterprise engineering?
Yeah, I find the word enterprise engineering quite interesting, because when I look at the word enterprise architecture, I would have thought enterprise architecture would do what enterprise engineering is claiming to do, which is basically engineer an organization, produce a organization through the various components that make it up. Looks like enterprise architecture, although looking at the enterprise, is really a lot technical than I would have assumed it to be. So if I look at TOGAF, the Open Group Architecture Framework, if I look at the Zachman framework with the 6 questions and the rows, yes, they are trying to look at the organization, but still from a very technical viewpoint. So then the term business architecture has come about. And one of my colleagues and friends, Amit Tiwari in Melbourne, is actually writing a book on outcome-driven business architecture. So that brings me to the question, we have enterprise architecture, we have business architecture, now we have got enterprise engineering. To me, enterprise engineering can be summarized as implementation of enterprise architecture. And to me, EA is very important from a big data viewpoint, because we have got things like the SMAC stack, which I have. SMAC, by the way, stands for social media, mobile, analytics, and cloud, SMAC. And it is impossible to differentiate between these 4. They are all a collection together. And they are a part of my view of big data enterprise architecture. Semantic web is my view, or my element in enterprise architecture for big data. So to me, enterprise engineering should start with enterprise architecture, and then the question to ask is, how best can I implement this architecture? That is enterprise engineering. So I'm not sure if big data can be helpful in enterprise engineering, But by doing enterprise engineering, I am in a better position to make use of big data at a business level.
Okay, great. I'm going to squeeze in one more question here because we are pretty much out of time, and then we'll go on. It says, you have not mentioned big data and agile application and machine learning. Is there a reason?
Then we have to mention the word IoT, because the way I'm seeing it, big data, IoT, and cloud are also going to be together, are already together. So if we look at machine learning, and I mentioned eyesight technology in most new cars, including the one that I'm enjoying driving around, then it is based on machine learning. But if I look at the amount of data that is generated by machines, then it is through the use of IoT, through the use of sensors in vehicles. And I showed you a picture of John Deere and the agricultural application of big data. A transatlantic or a trans-Pacific flight, air flight can generate 1 petabyte of data. That's all machine generated data. So if the question about projecting 10 years from now was a very valid first question, and I would say that machine learning will make sense when we are not just able to ingest this data that is coming in at high velocity, but also able to marry it with the existing data. So we have the problem, the challenge of velocity of data with existing data that we need to handle when it comes to machine learning and neuro-linguistic programming, NLP, and so on. So that's why, in one sense, I have treated it or clubbed it along with my IoT discussion in the overall BDFAB.
Okay, great. Thank you, Bhuvan. On that note, we're going to have to wrap up. We are over time, and we still have some questions left. We'll see about forwarding those on to you, see if you can perhaps write some answers down to the folks that have asked the questions.
It will be my pleasure, and I invite everyone to send me more questions. I think all these questions were very valid and very helpful in furthering my understanding. So thank you.
Fantastic. And if you think of a question after the session, we can still get those answered to you for you. You can send them to me directly to rwhelan, that's WHELAN @cutter.com, or you can send it simply to sales@cutter.com, and we'll get that to you. Once again, I want to thank everyone for attending. I want to thank you, Bhuvan, for having such an educational session. And we'll have to see if we can do just a question and answer session on this topic, as it seems we've really had a lot of questions come in, and a lot of good ones, as you said.
I'll be delighted to have a Q&A session, and it's a great experience.